Welcome back to Maths with Mrs. J. We've been talking about the unit circle and we've got used to, or hopefully are getting used to, the fact that we now think about sine of theta as the y value, cos of theta as the x value, and tan of theta as the y over the x. We also know that we can talk about the position or the angle in two different ways. I'm focusing mostly at this stage on our radians because that's the new part. And also because when we get on to differentiation and integration, that is what you're going to be focusing on. You need to be able to do that rather than degrees. So in the previous video, we talked about the fact that when we had this, what I refer to as a horizontal reference, so when you've got your theta next to your x-axis, what we actually found was that we kept the same trig ratio. So let's just write that down again. So we had the same, so horizontal, we had the same trig ratio, and we got our SIGN sign from all stations to central. So all of them are positive in the first quadrant. The only one that's positive in the second is sine. The only one that's positive in the third is tan. And the only one that's positive in the fourth is cos. And I said, please don't go home and learn all these things. It's totally unnecessary. All right. We're now going to do some examples where we can actually look at, you just go to the next slide, look at some examples and see how this whole thing is going to work. All right, now this might look difficult, and it probably is a little bit difficult for you at the moment. But what we need to think about is we can always draw a little unit circle to help us. So what we're going to do is we're going to draw ourselves just a little very rough unit circle, maybe here somewhere. It doesn't have to be fancy. In fact, that's very unfancy, but that'll do for our purposes. What we need to remember is that sine is the y value, cos is the x value, and tan is the y divided by the x. And we also need to think about our horizontal reference. All right, just thinking about our radians for a minute. This is pi on 2 up here. This is pi here, 3 pi on 2. 0 or 2 pi there. Cos of pi on 2, what's the x value there? Well, the x value there is just 0. All right. Sine of 3 pi on 2. Well, we're down at 3 pi on 2 and we want the y value. Remember, this is a unit circle. So it goes down to -1. All right. So that would be the answer for that one. Cos of pi. We're at pi here. What's the x value? Cos is the x value. What's the x value there? That's -1. And tan of 0 is going to be your y value, which is 0, divided by your x value, which is 1. 0 divided by any non-zero number is 0. If I did ask you what's tan of pi on 2, just for interest's sake, the y value there is 1, the x value is 0. Can't do that, it is undefined. Tan is undefined at pi on 2 and 3 pi on 2. And in fact, any number of times you go around the circle and then end up at these points, tan is undefined there. All right, cos of pi plus theta. Now, pi plus theta we're talking about here. We're in our third quadrant. It's a horizontal reference, so we know it's going to be cos of theta. We're just not sure whether it's going to be positive or negative. Now, I'm deliberately going to go through the process here of putting a plus if it is positive. It won't be in this case, but just to sort of make sure that we go through the process. So the first question is this a horizontal reference? Yes, it is. So we're going to keep the same trig ratio. All right. Then we need to say to ourselves, what quadrant am I in? We are in quadrant number 3. Is the x value positive or negative there? Well, it's negative. And we're done. All right. Sine of 2 pi minus theta. 2 pi minus theta. So we're in our 4th quadrant. It is a horizontal reference. So it's going to be sine of theta. Same trig ratio because it's a horizontal reference. Is sine positive or negative here? Well, your y value is negative in that quadrant. Tan of pi minus theta, you're going to be in here somewhere. All right, and it is a horizontal reference, pi minus or pi plus. 2 pi minus or just negative is always a horizontal reference. So it's going to be tan of theta. Now, is it going to be positive or negative? All stations, only sine is positive in that one, so this is going to be negative. Or you can think of it as, well, your y value is positive, but your x value is negative, so if you divide them, you're going to get a negative. Cos of negative theta is down here. It's a horizontal reference, so it's going to be cos of theta. Is it going to be positive or negative? Well, the x value here is actually positive. That is one that a lot of people mess up on. Please don't let that be you.